Electricity is indispensable for our lives. We've been heavily relying on fossil fuels and atomic energy for the generation of electricity. Today, with the increasing global demand for energy, we are facing many issues, such as the depletion of fossil fuels and global warming. To address these issues, various efforts have been made to increase the energy efficiency and adopt more renewable energy resources. These efforts need to be accelerated. To realize a safe, sustainable, and smart society where energy is consumed efficiently, Sumitomo Electric has developed various products and services in our Smart Energy Solutions portfolio. For the future of the Earth, it is inevitable to introduce more renewable energy resources as our energy source. However, there are some challenges in integrating these renewables. For example, with a large adoption of wind and solar energy generation, the power generation efficiency will be highly affected by wind and weather conditions. A power generation control scheme will be needed to increase the efficiency and avoid unnecessary power generation. At the same time, we need to make sure that there is minimum impact on the existing electric power system when integrating these renewable energy sources into the electricity grid. A large-scale energy storage system can solve these issues. For example, even with the fluctuation of renewable energy, stable power supply can be realized through the use of these large-scale energy storage systems. And power generation facilities can produce and deliver reliable power to the electricity grid. By charging during off-peak demand and discharging at peak demand time, the power generation facility's efficiency can be increased. In the event of an emergency, the large-scale energy storage system acts as an emergency power supply to ensure power supply to important facilities. Sumitomo Electric is the world-leading company to develop vanadium redox flow battery. In July 2012, Sumitomo Electric deployed the world's largest vanadium flow battery at our Yokohama works. The system is connected to an actual power grid and involved in the daily electricity operation at the manufacturing plant. The vanadium flow battery uses vanadium ions in different oxidation states as its electrolyte to store energy. One of the key features of this battery is that the power and energy can be designed separately. Energy can be increased by simply increasing the volume of electrolyte. Other batteries rely on chemical reactions to store energy and thus have degradation issues over a large number of cycles. On the contrary, the vanadium flow battery involves no chemical reactions to store the energy. So the battery has no degradation issues and thus has a long lifetime with unlimited life cycle. Also, since no flammable materials are used in the vanadium flow battery, it is a safe and reliable energy storage system. The vanadium flow battery that we installed at our Yokohama works is 1 megawatt by 5-hour system. This capacity is equivalent to the power supply for 500 households in a day. Sumitomo Electric has developed advanced concentrated photovoltaic system. Concentrated photovoltaic tracks sunlight and uses optical lenses to concentrate a large amount of sunlight onto small high-efficiency solar cells. In areas with high solar radiation, CPV can generate more solar power than traditional silicon photovoltaic systems and can therefore lower the cost of solar power generation. Each CPV unit is 7.5 kilowatts, totaling 100 kilowatts, with 15 CPV units deployed in this demonstration system. This CPV system can be also used as a digital display without sacrificing any output power. The space under the panels can be used for other purposes. The Energy Management System, EMS, manages and controls the power output from the CPV system and the operation of the vanadium flow battery. The vanadium flow battery charges during off-peak and discharges its stored energy during peak demand, so that the peak load on the grid can be reduced to realize peak load shaving. By combining the vanadium flow battery with the CPV system, the fluctuation of solar power output can be smoothed through the charging and discharging of the vanadium flow battery. The use of the vanadium flow battery for fluctuating solar power generation enables stable power output as planned and ensures scheduled generation. Sumitomo Electric is working towards the commercialization of this system through the demonstration of various functions and operations. We have developed SEMSA as an energy management system that achieves optimal operations of energy storage and generators. SEMSA controls energy storage and generators faster and smarter than people, and is a system that can automatically react to demand response, which is a method of assuring power company reserves and evening loads. It is also characterized by being able to control power sources independent of their equipment types. SEMSA contributes to minimizing customer energy costs, enhancing business continuity planning execution during emergencies, sourcing locally generated energy for local consumption, and promoting CSR. In addition, a redox flow battery system with a capacity of 60 megawatt hours has been installed in parallel in the Minami Hayakita substation in Hokkaido in cooperation with Hokkaido Electric Power Company Limited. For 3 years starting in 2015, redox flow batteries will be used to mitigate the frequency fluctuation by renewables and to shift the surplus energy of renewables from the off-peak time to the peak time. We are working toward further possibilities of redox flow batteries. Sumitomo Electric's large-scale energy storage system, concentrated photovoltaic system, and energy management system will support the next-generation power system. The Sumitomo Electric Group will continue to contribute to the creation of a safe and sustainable society.